Let's discuss the differentiation of algebraic functions. We have studied that there are four kinds of functions. One by one we'll take up all. As far as algebraic functions are concerned, we have just now seen differentiation of a linear function as well as a quadratic function by substituting the values of x to x plus dx and corresponding change in y to y plus dy, and we have found the ratio of dy and dx. That is quite a lengthy process. We are having some direct differentiation formulae by using which we can directly calculate the differentiation of a mathematical, or right now we are studying about algebraic functions. So first we are going to discuss the direct differentiation formulae. For algebraic functions, mainly we are going to study four formulae. The very first is, if y is given as x to power n, then corresponding differentiation of y with respect to x is written as n x to power n minus 1. You have to directly keep this relation in mind, and we need to apply this formula in various applications. Like the second relation is directly related to it. If you are given with y is equals to 1 by x, so using this relation only we can calculate what will be the value of dy by dx. You can see 1 by x is x to power minus 1, so here n will be minus 1. So the result will be minus x to power minus 2, so it will be minus 1 by x square. There is also a direct relation because it is also extensively used. Third one is also linked with this. If y is equals to root x, using the first formula you can calculate directly what will be the value of dy by dx for root x. This is x to power 1 by 2, so here the value of n is 1 by 2. When you put it here, it will be 1 by 2 x to power minus 1 by 2. So it will be 1 by 2 root x. This will be the differentiation of y if y is equals to root x. The fourth one, quite a simple one. If you are given with y is equals to a constant, any constant, we can directly state the value of dy by dx is equals to 0. Because if y is a constant, it will never change, so differential change in y is always 0. We can also apply these in various cases, like for an example, if we are given with y is equals to x to power 4 plus x to power 3, and we are asked to find dy by dx. Now you can directly apply this formula 1 into this particular relation to get the result. Like here dy by dx is equals to, if it is x to power 4, in case of x to power n, the result is n x to power n minus 1. So here if it is x to power 4, the result will be 4 x to power 3. Plus similarly, if we apply the differentiation to x to power 3, this will be 3x square. This is the answer to this particular question. Let's see some more example based on these relations only. Let's see one more example on differentiation of algebraic function. Say we are given with the y is equals to 4x cube plus 5x square plus 7x plus 8, and we are required to find the value of dy by dx, or the differentiation of y with respect to x. Now we'll apply the same formula to get the result. Here the value of dy by dx we can directly write by using the direct application. If we talk about x to power n, differentiation of x to power n is nx n minus 1. So it is x cube, so its differentiation will be 3x square. So 4 is already there as a coefficient, so you can multiply this 3, it will become 12x square. Plus, if it is 5x square, differentiation of x square will be 2x to power 1, so it will become 10x. Plus is 7x to power 1. So it becomes x to power 1 differentiation will become 1 into x to power 0, that will be 1 only, that will remain as 7. And differentiation of a constant is always 0. So this is our answer. Directly you can get the result by applying direct differentiation formula. Let's take up one more example based on these formula, direct differentiation formula for algebraic function. Like if you are given with y is equals to x to power 9 plus 7 by x plus x to power 5 by 4. Now also we are required to find dy by dx or y prime. Y prime is exactly the same thing as dy by dx. It is just a different way of notation, nothing else. Here, if we talk about y prime, you can simply write it x to power 9 differentiation will become 9x to power 8. If we talk about 7 into 1 by x, differentiation of 1 by x, we already studied as formula number 2, that gives minus 1 by x square. So it becomes minus 7 by x square. Plus for x to power 5 by 4, again the power is a constant. For algebraic differentiation, it will be n x to power n minus 1. So it is 5 by 4 into x to power 5 by 4 minus 1, that is 1 by 4. So this is the answer to our question. Let's take one more example for the similar category. Like you are given with if y is equals to 8x to power 7 plus 5 root x plus 3 upon x to power 6, and we are required to find dy by dx. Now you can quickly apply the relations what we have studied. Here dy by dx will be equals to what? 8x to power 7, that will become 56x to power 6 plus 5 into root x. Differentiation of root x is 1 by 2 root x. It will be 5 by 2 root x. And here it is 3 into x to power minus 6 we can write. So this minus 6 will come out. This will become minus 18 into x to power minus 7. So it can be written as 18 upon x to power 7, which is the answer to this particular case. Let's see a few more examples in series. Say for example, we are given with y is equals to 4x to power 2 by 3 plus 3x to power 3 by 2. And again we are required to find dy by dx. Here also we need to use the direct formula of x to power n. Here dy by dx will become 4 into x to power 2 by 3. So this 2 by 3 will come out. It will become 8 by 3 into x to power 2 by 3 minus 1. So it will become minus 1 by 3. Similarly, plus 3 into 3 by 2 is 9 by 2 into x to power 3 by 2 minus 1 is 1 by 2. This will be the answer. For another example, if we'll see, if we are given with y is equals to 5x4 plus 3x square minus 7 by x plus 8 by x square, and we are required to find y prime. So when we wish to differentiate, again we are going to directly apply the formula x to power n. Here dy by dx will be, I think now you can directly write, we have taken plenty of examples. It will be 20x cube plus 6x plus 7 by x square minus 16 upon x cube. This is the answer. I just leave it for you. Just verify all these terms how you are getting this result.